right.
Okay, can I start?
Yeah, no, I'll kick it off and then yeah.
Okay.
All right. So good morning, everyone. Happy Saturday. Yeah. Today we have Brunel, who's going to, and Ben, who's going to talk to us about some of the work that he has done. Before I even, so just want to thank Brunel. Brunel has been part of the group, I would say, for about a year now, and I know I've bugged him many times, jokingly, that he needs to present, but this time he finally accepted to present something for us. We really appreciate his taking the time to go through the studies and he's about to kind of talk to us today about some of the things that he has done in the past. I would say a couple of weeks to 3 weeks, a month now. So thank you for taking the time, Brunel. And I think Ben is also presenting, and I think Afis also is going to talk. But before the presentation, we just wanted to, Brunel, if you can just kind of introduce yourself for just a minute or two, and then yeah, we can get started.
Okay, thank you for the presentation. Hi, everyone. My name is Beifa Brunel Somda. So depending on how I met people, the close people call me Brunel, but everybody else calls me Somda. So I would say I'm involved in the tech industry, but I'm not a tech person per se. I ended up doing tech because I got a little bit frustrated with programmers. Let's say it like that. So I work on a few startups, and then usually while trying to build different solutions, I was in contact with developers. And sometimes the communication was a little bit difficult. And I noticed that it would be easier for me to just start building my own products. That's how I started doing a little bit of tech. So today I'll be presenting something that's very basic, because first, I'm not a tech guy. So for me, every time I hear about a solution, it's more about how can I take that and integrate it into the business world in a very simplistic way. So today's presentation will reflect that a little bit. So for someone who's more advanced, it might look a little bit basic, but we'll go through that and you'll see. So let me share my screen. Can you see? Can you see my screen?
Yep.
Okay, good. 1 second. Okay. So today we'll be talking about how to leverage AI for small businesses. And I decided to take the case study of pizzerias. So why exactly that? Because I was trying to come up with like a straightforward solution that a small business can implement. Currently, you have larger organizations. They have developers, they have engineers. They can help them implement these type of things. But usually, small business, they tend to be overlooked when they release a new technology. In the business world, we have a say where we say, if you want your product to be viral, you have to target women. But if you want your product to last, you have to target small businesses. That's why sometimes you notice technologies like VR and how to say, like you heard about VR and I would say IoT and all that stuff, because business, they didn't figure out a way to capitalize on that. That's why you heard about them, but they kind of died down. So I wanted to present a solution that will be simple enough to be integrated. That means the business won't have to change the process that they have right now, or be able to kind of reinvent the infrastructure that they already have in place. And also the solution could be replicated. Right now I'm focusing on the pizzeria vertical, but you'll be able to take that and just apply it to another vertical. And the solution is also simple enough to be built on. So we'll be covering the most basic AI solution ever. I think someone's trying to join. Okay. So like I mentioned before, the target audience is like individuals with non-technical background. And also people, they can have a kind of tech background, but they're not very familiar with how to implement AI. So the plan would be, you have two parts, right? The first part will be me. I'll be presenting a very simplistic solution, and Hafiz will help me with the demo. And then the second part, Ben will kind of present a more robust, more advanced, and more optimized solution. So far, any questions? Okay. All right. So feel free to ask the question whenever you feel like it. So this is the scenario. In a perfect world, from a client standpoint, I already have, let's suppose I'm trying to order a pizza. From a customer standpoint, usually you already have like I'd say a store that you're familiar with, your favorite store. Every time you see this one, that's like favorite, right? In this case, it's Domino's. So if I'm trying to order something, I can call the store. I can use the mobile app, go on the website, or just walk into the store and just order. But that's in the perfect world. In reality, you have more constraints because sometimes you have a budget constraint. You might be like, okay, I have only $30 and I would like food for 3 people. Or maybe I don't know the neighborhood, I'm traveling. I'm visiting a city, or maybe I just moved into the neighborhood, or one person is allergic to gluten. So you have all these different constraints. So usually what do? You cannot Google it, because if you Google, I'm trying to order pizza and if one person is allergic, you're not going to get the result. So sometimes they give you also flyers, or you can try Uber Eats. But you'll see that if you're trying to do that, this is going to be very, very difficult to kind of go through that with all these constraints. So that's why the solution was to come up with like a chatbot where you can interact directly with the chatbot and ask all the questions. So when you ask the questions, for instance, let me go back here. We used to work with a restaurant, for instance. Usually when you start calling, I'm pretty sure everybody noticed when you call and sometimes they say, hey, hold on a minute, because they're working on something else. So we're trying to eliminate this pain point. I'll show you something pretty quickly. So if I take the example of Brother Pizza, that's a pizzeria that, around the corner from where I live. Never been on their website, but for this project, I had to go to. So, 1 second. So that's the flyer, for instance, that they distribute to people. I'm pretty sure most people receive that kind of stuff, but you see, it's so difficult to navigate through all that stuff. And then you see they have some kind of deals. So, and the deals, they will tell you this is Monday, this is Tuesday. Nobody will be able to keep up with that, especially if you start receiving maybe dozens of them. So you cannot go through all of them. So, and if you go on their website, for instance, you see they have a small widget here. But even if I say, okay, let me try to, I say, hello. You see, just right away, they start asking questions. Most people will just leave. They'll be like, okay, no, I'm not going to do that. And if you want to go through that also, it's a very difficult process, basically. So that's what we were trying to eliminate by creating a kind of hub. So the hub will be like you have the chatbot that pulls the data from a data source, and then you can ask all the questions. So we have different ways to interact with the chatbot. You can use a terminal for the tech guys. You can use an API. You can interact with the chatbot via a web page, or mobile app, or a widget. The widget will be what I just showed on the page. So for this demo, we'll go with the terminal, and then the second part of the demo will be with the mobile app. So what does the solution look like? Initially, when I joined the community, I didn't even know anything about AI. I heard ChatGPT, but if you ask me, for instance, how do I put together like an AI solution, I didn't even know where to start. So, that's why sometimes you see me asking a lot of questions, but now based on my understanding, that's how I was able to break everything down, right? Usually when you talk about a solution, you can group that in 3 different components. You have the data source, you have the processing, and you have the delivery. So the data source will be where you're putting the data from. That can be a flyer, that can be a PDF document, that can be a CSV, a JSON, it can be API, or that can be like a voice. That's where you pull the data from. Then you have this black box, as I like to call, that's where all the processing happens. And then from here, you can distribute, you can deliver to the end user. So the end user can be interacting with via the terminal that we'll see in a few, or an API, a web page, a mobile app, or widget. So keep in mind you have these 3 different components. So for the first example, we're taking what the data source will be a CSV file. The processing will happen here, and you have and it will be interacting with via the terminal. So if you take the source code, right, you will have it's going to be on the GitHub. You'll be able to see it, but it's a very, very, very simple solution. So if you take, for instance, the CSV part, the application has just few files here that I'm going to go over. You have the menu.csv, menu.py, but how do they work together, right? If you take the data source, right, we kept these 3 components. The data source, that's where you have the menu. Let me put it like that. So you have the menu.csv. That's the file that you can ask your accountant or whoever is in charge of the inventory, okay, give me your CSV file. I mean, the menu. It's going to be in a CSV file that you can open with Excel. Then you have a small script here called menu.py. So that's the script that kind of interacts with the menu right here. And then you have the chatbot.py, a small script here as well. That's going to do the processing. And in order to deliver, you need a connector, a way to connect the external application with the processing here. So that's why we have the py here. So if I go back, the menu.csv, right here, you see it as a text, but most people will understand that you can open it with Excel and stuff like that. So you have and you see the menu.py, it's extremely simple. It just takes the menu.csv here. It's going to read that and try to organize it in a way which during the discussion, I noticed that it wasn't necessary, but I'll keep it here. And later on, Ben will be able to explain maybe we should keep or not keep that part. But basically, go back here. You have the menu.csv. This small script here will pull the menu here. Will do what it has to do and give it to the chatbot.py that's here, right here. So if you take here, you can barely notice that it's using OpenAI because the implementation is so simple, right? You just have to. This was more to for the key, right? I'll just go directly here. You just have to import the key, this part, and then manipulate a little bit the menu right here, and just this is where we're leveraging the OpenAI. So as you can see, everything happens basically right here. You just have to tell the chatbot, okay, extract the following information for the providing menu, that kind of things, and then the role. You say you work at a pizza restaurant and answering phone calls and so on. So you see how simple this is? You can just take the same thing and do it for something else. That can be beauty salon. They can be anything. You just have to follow the same logic where you put the menu or catalog, if you want to call it like that, and just right here, you just specify. So just very simple. We go from the menu.py, the chatbot, and how do you deliver to an external, to the end user? It's just this small code, as you can see, that will run a Flask server per se. So no, I don't want to be too technical, but this is just going to kind of create a route for the application. So if someone wants to connect, they will be just hitting this endpoint. So let me do a quick demo right here. Oh, I already started. So in order to start the Flask server, you can see in the instruction right here. You can just type Python like this. You make sure that you are under, like, inside the proper folder. because here, as you can see, I did a version for the PDF, another one for JSON, for another one for the API, where we're focusing on the CSV. So now that this is on, you can just ask, for instance, is it big enough, or I need to increase the font for you guys? Okay, let's see.
Yeah, I think you can increase just a little bit if you can.
Okay, let's see.
If you could please increase the size of the text, that would be amazing.
This one?
No, the text in it. Okay, it's good. I can see now. Thank you.
Okay, so here, for instance, like I said, we interacting with that via the terminal. It's just a simple question. I ask, for instance, what is the price of the margarita pizza? So by asking this question, it says, hey, the price of the margarita pizza is like $11.99. But for something like that, you don't need the AI for that, right? Usually it's when you start talking about something where with more constraints. For instance, do you have a veggie option? And if yes, how much does it cost? That's when you ask this type of question, someone say, yes, we do have a veggie option in our menu and give you the price. That's when you use AI. We don't use AI just because it's cool. It's because, like, if you trying to implement a solution like that, when you start asking in complex questions, you'll quickly realize that it's a little bit difficult to do that by using like if-else statement and try to respond that. So far we covered like easily. Oh, here I made a mistake here. I was using initially I was using like a HTML page to be able to display it, but like we just did what we did, we used like the terminal for it. But basically, you just have to focus on these three different codes snippets. So being able to implement a solution like that with less than 100 lines of code, I believe it's very accessible for most people, right? So the second example is more like, now we'll be using an API. It's a little bit more complex, but it's still simple. The data source will be an API. The processing will happen the same way, and then the delivery will happen via a mobile app. So
Brunel, I have a quick question, just to clarify. So in a way, the role of the AI here is to remove some of the pain of ordering from the customer, so that they feel more comfortable buying more and more.
I would say the first problem we're solving is to be able to find it, because once you decide to find, if I take a small, I live in Las Vegas, right? We have about 200 pizza places. So if I say I'm trying to find the best option, it will be pretty complicated. So what we're trying to create is like a hub. You create a hub where for the user, instead of trying to go on every single website or you read every single flyer, you just have to go to one place, you just chat, you say, hey, this is what I want. And the chatbot will do the job to go and find the location, because I can be like, oh, it's 11 p.m., which store is open? So the chatbot will know that and tell you, okay, this store is open, what do you want? And then after that, you'll be able to decide if you want to place an order, or you want to call them directly, or you want to drive them. Does it answer your question?
Yes, maybe a follow-up question. Does it mean that there's an opportunity for through the LLM to remember some of the preferences, so that the interaction is more direct? Somebody can, after the preferences are remembered, can just say, order me a pizza, and the tool in the middle will understand that this specific customer loves eating, I don't know, margarita pizzas, and just take the initiative to facilitate that.
Yes, no, it's doable. But for instance, for this presentation, for instance, if you see the next step, the next slide, the last one, the limitation, I said we have to work on personalization. But that was kind of beyond the scope of this presentation. But definitely, this is something that needs to be implemented if you want to release it. But if I take the example of the place where I went, where is it again? This place, for instance, I'm not sure they will kind of remember who you are. They just want to be able to just take your order, and then next time you can come back. So the short answer is like, it's possible and it's recommended, but the implementation will require more work, basically. For me, it was more about showing something that's extremely basic, and then someone can be like, okay, for me, it's critical to know and to remember the user. You see, when I say personalization, it's, you know, certain offers, for instance, right? You might be like, okay, you need to be 21 plus to be able to have that kind of. Imagine someone's trying to do that for like a nightlife or something. So you need to know who is asking that. But you know, depending on the vertical, that's what I took, a vertical that's pretty open, and then everybody can customize it the way you would like.
Okay, thank you. It looks like there's a question from Nana. Go ahead, Nana.
Hi, everybody. So sorry, I was a bit late. I'm actually a little more curious as to how the data source looks like, and if we're able to access the repo we are using.
The data source? Okay.
Yeah, I did see that. Okay, thank you. Okay. And also about the repo, is it possible for us to have an access to the repo so we go through the code? Is that possible?
Yes, definitely. Yes. We'll. Do you want to share it, Aziz? Ben?
Yeah. If you merge the latest code, we can share it for sure.
Okay.
That's amazing. Thank you so much.
The code hasn't changed since last time we spoke.
Okay. All right.
So yeah, for the data source, you know, I don't know, your questions, you want to see where it's coming from, or?
Yeah, could you please open one of them for me, like a PDF or a CSV? I'm so sorry to drag everybody back.
No, but it's totally fine. You see, for instance, here, if you notice, we have different folders, right? Here, the first one, the data source was PDF. I'm not gonna lie, I tried this one. I noticed that I thought it would be the simplest, but it's the most complicated because it's a PDF, whatever. So CSV, you have a version where you can, the data source could be in CSV, JSON, and the other ones in the API. So the reason why it's like that is depending on the use case. For certain businesses, if I take a restaurant, I'm pretty sure if I want to ask where is the menu, they're gonna send me the menu in CSV. But if I work, for instance, with IoT, usually they're going to send you data, so like JSON type of things. So that's why I was trying to cover different data, the different format. And then we can decide, you know, but this one covers most use cases. Maybe we need to use pictures or something, but other than that, you can customize it easily.
Okay, so actually I'm looking to work with PDFs and CSV, but I want to see the format in which the data is in. Can you please open the PDF if you're comfortable? I want to see it.
Yeah, okay. So like I said,
so there's not a PDF file.
Can you say it again? Here the PDF file right here.
Yes, that one. Could you please open that for me?
Okay, I have to open it. If I open here, it's gonna be weird. Let me open it from here.
Because the use case I'm trying to see is how best we can format the data for the module to understand.
Okay.
Okay. Yeah.
But even this, for instance, that was a menu that was kind of generated. I generated the menu from a script, because in reality, if you take Toner Pizza, for instance, right? And if you take the Toner Pizza, in reality, that's what the menu looks like. You see, that's how they look. So usually, if you try to talk to them in a real life scenario, if you ask a business, send me your data, they will send you, either they're going to send you a picture like that, or they're going to send you like a CSV. So, but definitely you can, if your PDF is formatted this way, it will be able to work. But I didn't fully. Go ahead.
No, I was just saying thank you. This is amazing. Thank you so much, boss.
Oh, you're very welcome.
So my question is more, sorry. So you're saying that businesses, like, I guess my question is more along the lines of, how receptive are businesses with kind of like this kind of tooling, right? Like, you know, having maybe the data go into an AI tool, for example.
Okay.
In terms of their data and maybe their menus, especially if you're gonna build a hub. Like, do they have any concerns in terms of, oh, I don't want my competitor to see, you know, some of my stuff, for example? See what I mean?
Not at all. Usually, businesses, they want to be discovered, because that's one of the most difficult part. You create your business, you make your investment, and you want to be discovered. So, and sometimes competing with, you might have a better product, but because nobody knows about you, it's a little bit difficult. So when you have a hub, because think of the Mosaic hub like a Google. I don't know what's behind. When I ask the question, everybody's equal behind Mosaic. So it will be basically, give me like pineapple pizza, something like that. It's going to go and grab it. So now businesses, they will feel like, now I have a chance to sell something. It's not about marketing. It's about targeting the right person, like kind of thing. So, and if you take a business like this one, for instance, right? Like from experience, when I look at it, maybe they kind of hire someone who build that quickly for them, right? And then right now, if you tell this business, for instance, right, if I want to order, I have to call someone. So right now there's someone on payroll. If you tell them, for instance, that they will pay you $19.99 just to be able to have a widget that will take that and just send them the orders and stuff, they'll be more than happy to do that. So usually they're pretty open to it. As long as you're not going to change the way they do business already. You see, this one is there, but nobody's going to use it. So if you give them a widget, they can just copy paste, and then they can interact with the chatbot like that, they'll be open to it.
Okay. Thanks, sir.
Yes, Abby.
I would like to also mention that this is just public data, right? It's not like it's private data. You can get a pizzeria menu from just walking in their store. You can get it from their website. So it's not really like data that is sensitive. That's what I wanted to add.
Yeah, you're right. So the last, I mean, the example with the data source being an API is even simpler, right? You have the API.py. Let me open it again. I believe this is one. So you have the API.py. This part will just connect to an API, right? The API, I know this is also beyond the scope of the presentation, but basically you have a backend where you have all the offers. They already organized a certain way. That can be like something that's organized like, you know, Uber Eats and stuff. So this entire part of the code is just to be able to connect to the endpoint and just pull the offers. So the real thing happens almost here. Usually you will be hiding all this data into environment variable type of things, but to make it simpler for everybody, I just kept everything here. So you have this function that will, you know, get the offers. So once you get the offers, the chatbot right here will just do the same thing. You see, this code is not even different from the one with the CSV. They're almost the same. It's just like for the API, because we have more data from the JSON file, we have more data. We have like the name, the price, the short description, and then we can attach pictures and stuff. So that's why you'll see, but basically it's almost the same. And sometimes you don't even need to format it. You can just parse it and just work with it. So that's the chatbot.py, and then the app.py is also the same, where you run your Flask server. So I will ask Afiz if Afiz could share his screen, because this solution has been deployed to a server very easily, like Heroku. It just takes 5 minutes to deploy it to a server. It has been deployed, and now Afiz built like a mobile app that connects to the to this endpoint, to the endpoint, and then he will interact with the backend, basically, with our mosaic. So Hafiz, oh, there's a question. John?
I have one.
Are there any
Thank you.
programmers in this group? Or data analysts?
Say it again.
Are there any programmers or data analysts in this group?
Okay. Aziz?
Yeah, no, we can wait. Those kind of questions can wait until the end. So if you don't mind, Northlake. But John, go ahead with your question.
Sure. One more time, could you show the Python module that does for PDF parsing from reading the menu?
Okay. Funny thing, that's the one I didn't even test and completed because I gave up on this one. But here we go. It's extract right here.
Okay, thank you.
Okay.
Very good.
Okay. Okay. So Hafiz, you want to?
Thank you. All right. So a brief introduction of who I am. I'm Hafiz Torre, and I'm more of like a full stack developer, and I'm also an Army vet. And then I'm into businesses as well. So that's a short background of who I am. And then now I'm gonna show my screen and present the user interaction part. So 1 second, please. So share. Can you guys see?
Yes.
Okay. So I'm using the emulator here because it's pretty much easier, and then I don't have any Android phone right now to test it on. So this is the mobile app right here, and then just to show you guys that it's actually like an emulator. So if I just close this right here, and then it's just a regular phone. And then once I run the app, I also have it here, but I'll run it directly. Let me know if you need me to increase the size. So what happened?
Yeah, it's possible. It's possible that.
Yep. So it's gonna hide the top part for a little bit, but let me just do that, and then I'm gonna scroll. And technically, you start the app and scroll this here. Here we go. You start the app, and then you are introduced with a welcome message. Hello, how may I help you? And then here, let's say the best example of the app, right? So, and also the difference between this app and stuff like Uber Eats or like DoorDash is because this is something that allows you to quickly just, act for something on the fly. If I was to place an order on DoorDash, I would need to know what I want, and then I will go through the list and then find out, okay, this is how much, and then I'll add them up, and then, worry about delivery fees, taxes, and all that. But with this app, technically all I'm doing, I open the app, and then I'm gonna ask a question, a simple question. So, hi, I have $40, and I am interested in some pizzas. Could you provide me with an offer? Let's just put it that way. And then I send it. And then someday your server sleeping again. Okay.
Using this server, so it sleeps after 30 minutes. You're gonna have to redo it again.
Yeah. So I have $40 and I would like some pizzas. Give me an offer. So the first time, the reason why the first one didn't work is because the API, technically the API is on the free server because someday it's cheap. And so when you do it the first time, you have the server will start would get from idle. And that's why the first one did not work. So if I send it now, normally, here we go. And then this is the message I sent. Hi, I have $40. I would like some pizza. Give me an offer. So good choice. With $40, you can get an Hawaiian pizza small for $13 and margarita pizza for $12. And then there would be a total of $35. So now this is what I'm gonna ask. What kind of drink can I get with my remaining $5? And then we offer a list of drinks, and then you can get some iced tea, soda, and so on, and any of these options. So technically, this is the difference between pretty much using an app like this versus using DoorDash, where you're actually going to have to go through the list and all that. So some advanced features that could be added could be like placing the order. When you're ready, you're like, okay, you know what? I would like to order from the best pizza store in the area, you know, and then use the reviews as a benchmark for, you know, deciding which pizza store is the best. And then, or you can provide the pizza store name, and then you will just place the order and all that. So you don't have to go through the list, looping through, finding all that stuff. So now that the demo is done, if you guys are interested in how the code works, I can present it. But I'll give you guys like a second to let me know if you have questions and like the demo, like the code.
Okay. So thank you, Hafiz. So I will just wrap things up pretty quickly, and then Ben also will be able to present the more advanced version. Sure enough.
Oh, Eastern.
Can you see? Okay. Can you see?
Yeah, we can see.
Yeah. Okay. Yeah. So basically, it's pretty much it. It was, like I say, it's a very simplistic solution, right? And then, I mean, the limitations / next step, like you need to build like a solution to upload a large number of menus. If you're trying to cover an entire city, you might end up having like 1,000 menus. So you need to figure out a way to enter that. You don't want to do it like manually. You need to add something like a voice chat. It's funny because yesterday, I believe there's something that happens with that shows that you need to add like a voice chat because it's a little bit easier to talk to the chatbot than typing. And then the personalization to be able to know the user, so you can even recommend something based on that. So that means like the user will have some kind of profile type of thing. But like I say, that's if someone's trying to do it. But right now it's just like a Google. You just go, you have an input, and you just ask what you want, and it's going to give you, and you can take it from there. So if you guys have questions, I'm open to that. Otherwise, I will leave the floor to Ben so he can present his part. Thank you.
Hey everybody, let me share a link. 1 second.
Put my phone number in the chat.
Sorry?
I put my phone number in the chat. Looking for a programmer or data analyst.
Okay. Yeah, we can have a discussion maybe after the presentations at the end. Okay, so let me share my screen. Did everyone is everyone able to access the link?
Yes, I was able on my end for sure.
Okay, so let me share my screen real quick. Okay. Is it visible for everyone?
Yes.
Yes.
Maybe
Okay.
increase it a little bit, just a little.
Oh, sure. Let's do this.
Okay, that's good. Yeah.
Okay, so maybe let's start with a picture. So let's open this one. Okay, so what do we see here? Like in the image in the image description for the meeting, we can see Lego blocks. Like obviously, I didn't draw it. I asked ChatGPT to do that, right? So for quite a few meetings now, we've been looking at different ways of interacting with large language models, right? We saw a number of libraries, a number of concepts like prompting, prompt engineering, function calling, and many other things, right? So in my mind, I'm assuming that everyone is familiar with Legos. The way I see all of this new information, as I see all of those pieces of information as pieces of Legos, like all scattered on the floor, right? And that takes me back to childhood when I was playing with Legos. At some point, I would mix all of the pieces from different sets, and then I would just dump into the floor, and then it's a big mess, right? But the cool thing with that is that when I will merge, when I will dump all of the pieces from different sets on the floor, then I will start observing, right? So I will observe and notice how some of the pieces could potentially be assembled with other pieces from different sets, right? And then it's only a matter of time before I feel the itch to maybe assemble a completely different set that has nothing to do with what came in the original box, right? So in the same manner, when I look at code in general and more specific, what we've been seeing throughout the different meetings, I see all of those pieces of functionality as Lego blocks, right? And in my mind, every time I work on a new project, I don't want to keep too many details in my head because it prevents me from thinking about the actual problem that I want to solve. And for that reason, with this Lego analogy, I want to put the pieces together to form blocks that have a purpose. And then I can start composing those blocks into new structures. So I don't know if I make any sense. Are you able to follow?
There is some technical words there. Can you explain them, please?
Sure. So I have some links in here. So let's actually let me start by an example. We just saw the presentation of Brunel, and he showed how he's able to directly interact with the LLM by passing it the pizza menu details, and then the LLM is able to make a recommendation out of that. So I'll show you one high-level piece. I think I took this part from directly from his code, like the CSV. But let me start at the beginning. So I have an entity here which represents an order from the pizzeria, right? And the first field is a message from the pizzeria owner to either confirm or deny the order. Like for example, if somebody doesn't have enough money to pay, the owner can just deny the order, right? And then we have a list of pizzas because it can be a party in which people will eat, I don't know, 3-4 pizzas total. You know, there's a list for drinks, a list for sides, and then the total price. Okay, and then to place the context so that the LLM is helpful, I have a system prompt over here. And what does it say? Hey, my name is Mario Luigi. I hope I'm not being offensive. I was just thinking about Mario games. So my name is Mario Luigi, owner of the best pizzeria in town. I'm here to, let me zoom in a bit. Okay. I'm here to basically to help you select and place your orders. And then there's some restrictions that are added for how it should respond, right? And then the CSV file that Brunel showed earlier in his presentation, I just copied the text inside of it and just pasted it here. So that's this whole thing over here. So you can see how it contains pizzas and the price and drinks and so on and so on. It's actually just this block over here. Okay, and then like I mentioned earlier, when we interact with the LLM, there's different techniques. Like one of them is prompt engineering, and as part of prompt engineering, there is something called a chain of thought. So I integrated part of it in here by providing examples, right? Since this could be a bit nebulous for the LLM to process, I don't want it to, I want to restrain the chances of the LLM like to start hallucinating, right? So through chain of thought, which is one of the techniques of prompt engineering, I'm giving an example of an order and an example of a correct answer, depending on the scenario, right? So the first one, like I would like to order a margherita pizza, a Coke, and some garlic bread. And then one correct answer could be the order, which is 1 margherita, 1 Coke. Like notice the numbers: 1 Coke, 1 garlic bread, for a total of $14.97. And this price, I haven't verified the math, but I'm assuming the LLM knows how to do some basic math, right? So the total should be the addition of the prices for the items, you know, and then another one for this price. And then as I use this example to try to throw off the LLM to move away from the, if you want, from the happy path, right? Here I'm ordering pizzas. I mean, I'm ordering fries, but it's a pizzeria. So obviously that can happen, right? So in that case, it's a denial. Sorry, we do not have fries on the menu, right? Another bad case, I think, is I would like some free food. Sorry, we do not have free food, and so on and so on. Yeah, like this one, I want a Hawaiian pizza, but I only have $2. Nope, can't happen. I only have 5 cents and I want to eat all of this. Still no. Right? Now, let me see if I can retrieve a previous code from a previous presentation. Let me zoom out 1 second. So file. If I go here. Okay. So a few weeks ago, Derek made this presentation, and actually I can share the link with you. So Derek made this presentation, and there was an interesting part.
I need you to do something.
Hey, Constance, you put on mute.
Shh. I thought I was on mute.
Sorry about that. Okay, so there was during Derek's presentation, there was we had this this module here called LLM.py. It's in the repo I just shared. And what does this one do? It has a prompt to generate some SQL statements that's gonna run against the database, right? So we have this helper function here, but the function itself like requires a client. And to set up the client, we have all of these boilerplate, right? Including the imports and all of that. You know, and then we have variations for the case when the API call is non-blocking, right? So in a way, we require a whole file just so that we can interact with the LLM, which can be distracting from the purpose of implementing this project. So if you compare this to that, basically the whole boilerplate that you saw, once we start putting the Lego pieces together and recomposing them, we can end up with something like this as an abstraction, right? So in this case, it's just a Python decorator. We specify the context. This is what we saw on top, and then we specify the model that we want to use, right? And this decorator decorates this function over here. And when this function is invoked, like we can see here, test pizza, we only have to pass the prompt. So in this case, the prompt is this one. I would like to order food, and I only have $5, right? There's no need to pass the second argument when we first invoke the function, but magically, when this function is invoked, this input will be populated with the proper data that we can log. So then let me show it. Let me run it so you can see. Oh, wait. We need to enable the environment. Wait. Maybe I'll do it from the terminal. 1 second. Oh, I think I know what I did wrong here. So, yeah, I made some changes this morning, so I need to simplify this one real quick. What did I do here? Sorry about that one. Deactivate. Okay. So from that pi, maybe I should change the model here. So that. And so sorry about that because I just did this one last minute. This is complete odds. Okay. Okay, I'll revisit this one later, but trust me that the input is populated, and then this one will print. So So if I switch back to the steps here, these Lego blocks that I was referring to, in terms of code, they present themselves they can present themselves as what's called a domain-specific language, right? So a domain-specific language is this is an example of this. Instead of writing boilerplate code, we can use terms we can use abstractions so that we can directly refer to the boilerplate code as one thing, as a term. Like, for example, when you want to interact with a SQL database, there is a purpose-built language in order to make queries. So SQL is one example of a domain-specific language. It fits the domain of inserting and retrieving data, right? So in this specific case, prompting, like the prompt decorator, is fit for the purpose of interacting with the LLM without having to worry about the tiny details behind the scenes, right? And I can show you how. Okay, so the DSL, the decorator itself, that you saw, the app prompt, it's connected to this notion of higher order functions, and I can show you the implementation. Okay, so if we go here, the link to this one is in here, like the Instruct easy. Okay, so the prompt that you saw is this one. So what do we have as parameters? We know that when we want to interact with a large language model through a library, in this case, the instructor library, all we care about is to provide the context, also provide the specific model we want to use. We care also about the maximum number of tokens to use, and in the case of instructor, like how many times it should retry in case of failure, right? Yes, go ahead. You have a question?
Once the max number of tokens is reached, what happens? Does the message get cut off, or the whole call gets canceled?
Well, in this case, it depends. If it's okay, so instructor, let me switch back here. So with instructor, the instructor library, basically we need to specify a model, right? And all of those fields here, when the response comes back, the response is transformed into the structured object, right? So in the case that the tokens go beyond, I think two things can happen. If the transformation into the structured object fails because there's some missing data, then the call is not going to proceed, right? In ChatGPT, I think it prints, and then at some point it just stops.
Okay.
Right? So if I was just retrieving text, then it wouldn't be a big deal. The text would have just been cut off. But in the case of the instructor library, since we want to retrieve structured data, if the data is incomplete, it's possible that it may throw an error.
Got it. Okay. Thank you.
Okay.
Just to add to that, I've had the experience last time when I did that presentation on the scrapers. Basically, the API will give you an error to say that you've exceeded the number of tokens you need to use. So you may need to like revisit, maybe clean up your code or do something to reduce the number of tokens. So that's my experience.
Got it. Right. Thanks.
Right. Okay. Okay, so so like I said, I made a push this morning. I think I broke something, but let's continue. So this is the first. This is the top level function, right? So in this case, you can see that in the inputs there's no function. However, the function declaration stops here, and then from line 7, it declares a whole block. See, it declares a whole block that starts here and then goes all the way to the end. See? So in a way, this function, this top level function prompt is a function factory. It's a function that returns a function, which is the exact definition of higher level functions, right? And in the function that it returns, the function that it returns itself accepts a function as an input. What is this function? This function is the one that we create when we want to use it, right? So this one becomes an input to the function which is returned by that decorator. So we have 3 levels of functions. I don't know if that does it make sense? Okay, so I can say it again. So the prompt returns a function, and that function accepts the test pizza as an input. And then what does it do? It tries to, it verifies that, it checks to see if that input function, which is test pizza, if it's an asynchronous function or not. So for example, if this one was async the def test pizza, then what will happen is that it will run this if statement, right? And in this if statement, it will take care of assembling the boilerplate code and set up the call to interact with the LLM, right? And then once the setup is complete, it's actually going to invoke the LLM, collect the results. So it's going to invoke the LLM like this, and then collect the result into that completion. And then at that point, the original function that was passed, which is the test pizza, will be invoked, right? So it will be invoked with what? It will be invoked with the original message, as well as the return data from the LLM. Yes, go ahead.
Thank you. Quick question. What is the I caught you were using the wraps decorator. What's the advantage of that?
What's the advantage of wrapping everything in decorators?
No. What is the advantage of actually using the wraps? WRAPS
Oh,
decorator.
the wraps. Okay, I can show you. So okay, so here I have a basic decorator, right? There's no, actually I deleted it. Okay, it's possible to create decorators without the wraps, but in this specific case, having the wraps is important because in the Python runtime, Python will make sure to capture all of the metadata of the input function. So that, for example, when it's invoked, if for some reason something breaks, the stack trace will contain the information of the original function, right? But when we create a decorator without the wraps, like for example, if this line was not there, it could still work, but then when it breaks, it will be local to the decorator itself. It's possible we wouldn't have any reference back to the original function. which will make it difficult to debug. I hope that answers your question.
Yes, it does. Thank you.
Yeah. Yeah, okay. So this is one, like once the boilerplate is invoked, the original message is passed back to the original function. So, okay, so the original message is message, right? Message is the first input, right? This one by default is none. The fact that we put equals none makes it so that we don't have to specify it when we call the function, right? But then, since the boilerplate code, which is wrapped in the decorator, will run first, even though we're calling the function, that part here doesn't run right away. It runs last, right? And since it runs last, in a way, this prompt, if you want system over here or tooling, will take care of calling the original function for us. And that's what's happening here. So since it runs the boilerplate and knows how to interact with the LLM directly, right? Then it directly provides us the result of that call to the LLM, right? As structured data. And the exact structure of that data would be that pizza object. Yes. And since it's that pizza, so it means that we start with an empty or a null pizza object, but we end up with magically with an actual pizza that we can use to do anything inside the function. So in this case, I'm just printing it. Right. I think I don't know what I missed here. Okay, I'll debug this later. Does it make sense? Okay, so let's proceed. So you can see that. Let me clear this one. So you can see that there's an advantage of using decorators, and the cool thing is that since decorators are in a way they are self-contained, you know, they are almost like Lego pieces that we can recompose together, right? So I have a dummy example here in which I create a couple of decorators. So I have decorator 1, decorator 2, right? And just like we saw for test pizza, we have a function which is wrapped this time by 2 decorators. So what could be a good use case for that? Well, like I was saying, the pieces of Legos at first were all scattered on the floor, and now I start to stack them together, right? So my reason for stacking them together is because I imagine that, hey, it would be cool if one of the decorators could do some work, and then once the work of that decorator is finished, the result gets passed to the next level, to the second decorator, right? And then when this one is all done, then eventually it can pass it to the original function, right? So I have 2 variations of the same thing. So I have decorator 1, decorator 2, and then 2 other decorators that accept some inputs, right? So it's gonna use the decorator 3 is gonna use that initial value, use it to do some work, and then the result of that work will be passed to the next decorator, which itself will use an initial value and combine it with the values coming from the decorator upstairs, and then take the whole thing and then process it and then pass it back to the original function. Okay, so let me run it. Okay, so what do we see here? So if we look at this case for the decorator 1 and decorator 2, but by the way, this is also linked into here, so you can have access to the repo that way. Okay, so what do we see here? We have an initial value from decorator 1. So let's see. Right, it's just a string. So this string is this one, right? And it's printed on this line. And what does it do? Since it accepts the since it wraps a function, meaning that it accepts it as an input, then it's using this initial value as the second input to that function that it wraps, together with the parameter that this wrap function accepts, right? So this is the print statement from the first stage, and then we have the second stage. In the second stage, what do we see? That second input is this one, right? And it gets combined into yet another value, which is called the derived value. And as you can see in the statement, that derived value is itself derived from the input decorator, which is this one. And this one is nothing but the value from upstairs, this one. And then finally, after the additional processing at the level 2, we pass that pre-processed data, which is combined of many parts, back to the original function. And then in that case, it prints all of this, right? So the original, that function, which has decorator 1 and decorator 2, has a parameter which is example. So you can see example here. So we have example as the first parameter, and then the second parameter, input from decorator. What is it? It's a value from decorator 2, which is derived from the input decorator, which is nothing but the original value from decorator 1. Does it make sense? You can ask any questions if you like. Okay, so this is very similar to decorator 3 and 4, except that the decorators themselves accept an original input value, right? So in this case, they mimic closely what I had in here. In that case, the prompt was accepting the context, which is the details about the pizza, the pizzeria, and the pizzeria owner, as well as the model. So it's that use case over here. And where's my file? Right? But instead of doing it with one decorator like we saw with the prompt, I'm stacking them together so that there's even more data to process. And then again, the original parameter, which is other example param, like this one. What did I print? Yeah, it's this one. Yeah, okay, so other example param, which is this one, sorry. It gets combined with all of the data processed in the 2 levels above of decorators. Right. So seeing this, it looks like a very complicated thing for no, I mean, it seems like for no reason. But to make it more concrete, I have this example here. So same thing. we have a context. In this context, I'm telling the LLM to take up the role of a software engineering professor, right? Who's gonna help the student who is the person prompting to get the coding tasks done, like done quickly, so that they can graduate early, right? And then I have some constraints, like for example, the init file should be added to the folder so that it makes up a proper package in the case of Python. Right, and then finally, if there is a need for it, a project file should be also created, as well as the dependencies, and also make sure that the extensions are correct. Okay, so what do we see here? The first level this time is the prompt that we saw earlier. And then the second level, we have a different decorator. What is this one? Let's take a look. So in the tools package of the instructor easy, I have this object here that represents a file. So the fields are file name, file content, file path, to indicate like the path where it should be saved, or the directory, and the file extension, the file mode, to see if to determine if it should be an executable file and things like that. And then the file encoding, like if it's UTF-8 or some other thing, right? And then, just like we saw for these decorators 3 and 4, it accepts an initial value, which is the base directory where the files will be written, okay? And then since it's a higher level function, it returns the actual decorator, which is decorator file writer. And this one accepts our custom function, which lives into the, like our code where this file writer decorator will be used. And in this case, we already assume that something is gonna come and populate the second input, which is null by default. And notice how the second input is a list of those file details, right? And you can notice the similarity with this use case over here. We have some text as inputs, and then as an optional input or optional parameter, we have an input that has a certain shape, right? So in this case, the first input is a string, and then the second input is a list of file details, so it has a certain shape, right? So the first thing that we do is what? We make sure that the original, the specified directory exists on disk. So we need to create it. So we just use the Python standard library, like the OS package. So os.make_dir, and it's going to create the directories. Okay. And now, since the input is a list of file details, we just look through them, and then we use the path, the contents, and extension to basically write these files into the specified directory, right? And then once everything is done, then like we saw earlier, we pass the original parameter together with that second parameter back to the original function, and then we return. Does this part make sense? Okay, so let me switch here. Okay, fingers crossed, because I was running this one this morning. Hopefully it still works. Actually, let me let me rename this one. Factor. Those are some of the files that I was generating this morning. So I'll change them to backup. So you can see like generated a bunch of stuff. Okay. So the prompts here to the professor is what? In the first case, I have a Python assignment and I want the professor to help me generate this function in Python, right? The Y combinator. If I remember well, the Y combinator is an anonymous function that can call itself recursively. You can look at it on Google. And then I need to do the same thing this time in Ruby and then in JavaScript. I tried Lisp, but it was complaining about some stuff. It was breaking, so I commented it out. Scheme worked, and I have NIM, which is very similar to Python, but it's a native language that compiles to C or C++. Okay, so let's run this. Okay, so we can see the prompt happening. And then the second prompt. And then the third one. And take a look here. At some point, the folder will be created. Okay. Okay, it's all done. So let's see. Refresh and see. Wait, where did it go? Okay, maybe my ID doesn't refresh here. So let's see, ls. Which one's it? Oh, okay, I know what happened. I need to run it again. When I renamed the folder, like my ID also changed the string. I'm sorry about that. Let me run it one more time. So let's run. Okay, so it should recreate this folder without the underscore bk for backup. Okay, it's done. So what do we see? We have a bunch of files for all of those languages that we specified, right? So we have JavaScript. This is what the Y combinator looks like. Like I was saying, it's a higher level function itself, right? So you can see it accepts a function which returns a function that you can kind of read it for yourself. There's the same thing in Ruby, right? It even added some examples. Obviously, we have the Python version. Let me see what else. We have it in Scheme. We also have it in NIM as well. Like I said, it's very similar to Python. And any questions so far? No? Okay, so let's continue. So if I switch back to the document here, let me see. So we saw that analogy with Legos, right? And the way to do Legos in code, specifically in Python, is to use higher level functions through the decorators and context managers and so on, right? So imagine the pieces of functionality, like basically how to make an API call to invoke ChatGPT or to invoke Anthropic or to do X or Y or function calling. We started putting them together through the facilities of higher order functions available in Python. And then we started stacking the pieces together. Like we saw decorator 1 stacked on top of decorator 2, stacked on top of a custom function of our choice, right? So since those decorators are portable and self-contained, we can reuse them in many different scenarios. We can even combine them in order to give more a specific purpose to a piece of functionality. Like we just saw, a function which has 2 decorators, one for prompting an LLM and another one that just knows how to write files to disk. The 2 are combined to give us a function that can generate code, any type of code, right? According to the context and the prompt that we give it, right? If for some reason, where's that file? So if for some reason we didn't want to generate code, but we wanted to generate, let's say, CSV, then all we will have to do is to change the context as well as changing the prompt, and then the folder would start containing CSV files and so on and so on, right? So in a way, combining a prompt to an LLM with a tool like file writer, we can generate a better functionality in a very portable way. So in this tools package, you can speculate and kind of like see where this one goes, right? Eventually, the toolbox can contain many more types of tools, not just the writer, but maybe something that knows how to do API calls or do some other useful thing in a portable way. And then in code, we pick the tools and decorators that we need to enhance our functions, and then do stuff, do some useful stuff, right? So with that in mind, potentially, since there could be many tools, no one can predict how many, we end up back into the original situation. We end up this time with a bunch of tools scattered on the floor, just like the Lego pieces that we started with, right? And since they are all scattered, then we can start to think about ways to combine them to build other types of structures that are even higher, right? So let me see how I mentioned it here. So we saw the tools, we can compose them, right? But then we can, and these tools have a purpose, right? Like the file writer, its sole purpose is to write files to disk, regardless of the types of files, right? It just needs the content, the path, extension, and all that, and then it does its thing, right? So if we assemble all of the tools that we're gonna create in the future and compose them, right, we end up with multiple purposes, right, that can be assembled together into an even higher purpose, right? So let me show you an example. I didn't write it. I found it on GitHub. Let me share the repo with you. So this one doesn't, obviously doesn't use the small library I created. It's a different code base altogether and the purpose of that code base is basically to help the user create a game. Okay, but looking at what it does, that code base, in that code base, there is functionality to interact with an LLM. There is functionality to write files to disk. There is also a functionality to basically assist the user, you know, and provide feedback in a way that we end up with a game. Okay, so I'll just show you the. I'll do a quick one so that let me rename this one. Okay. I just want to show you how it runs. Let's see. Crystal to all its agents. Okay, so here it's asking me if I. So since here there's a warning from the author of that repo, basically that's saying that there are risks because it's gonna make some create some files. Basically it's gonna have file access to my machine. So if I want to continue, I need to confirm. So I will do yes, and then it's asking me what type of game I would like to generate. Okay, so I can say that build me like, do you have an idea for a game?
Yeah, the snake.
Okay.
The snake game from childhood.
Okay. Create a snake game for me. Okay. And now, since it's going to interact with my LLM, I mean, using my API keys and all that, the author made sure to have this additional question for how many iterations. The iterations here refer to how many times the LLM should be invoked in order to refine the details of the game, like basically plan the game, you know, before it actually goes ahead and creates the files for the game and write them to disk. Okay, so I would say like 4. So we're gonna see it running. I modified it slightly on my machine because I was running into some usage restriction from Anthropic. You know, so in the original version, the interactions with the LLM are done in parallel, but I switch it back to so that it does it one at a time, so that I don't run into the restrictions. So it's gonna run a bit slower. So here you can kind of see the steps of the game, right? We can see that there will be a main.py, game.py, snake.py, food.py, constants, and so on and so on. Right? It's almost done planning. Okay, so now that it's done with the plan, it started so it started stubbing the functions. You can see spawn, but there's no implementation and so on. And now it generated the plan in XML. right? So now it's gonna send that plan, I mean the details of that plan to the LLM piece by piece. And then when the result comes back, it's gonna write it to disk. So the first thing it wrote was the plan in XML format, and now it's writing the main.py, and now it's working on the game.py. So after it's done generating the files, it's gonna try to start the project. And when it starts the project, if there are any errors, those errors will be collected and then sent back to the LLM with the previous concept, so that the LLM understands that it needs to adjust the code in order to get rid of the errors, and then it's going to come back again and write more files to disk and then try running the game again. So I'll let it run until it starts running the game and runs into an error. And then I'll show you like a fully implemented game that I was able to generate with that code like this morning. Okay, so you see it started, it tried to run the game, it got an error, and you see what it says? Sending all files for error correction, right? So I'll show you what the game, like a game that I generated this morning looks like. Oh, see, this is the snake game. So it actually worked the first time. Oh, wow, okay. So you got official. I think you're more lucky than me, because
Cool.
when I was trying this morning, like I let it run for like an hour or more. It kept making mistakes. Okay, so this one is gonna keep running. So if I switch here, see what it says? Game is running. Please play the game. Close the window to stop. Okay. So if for some reason while playing the game crashed and had an error, the prompt will have switched to ask me for feedback. Okay, so let me close this. Close. Okay, so yeah, so you see it's asking me for feedback. So if I want it to make further changes, I will tell it, and then it's gonna rerun that same loop again. But let me show you the game that I did from this morning. Is the run. Okay, so this morning it was a guessing game. So I did not write a single line of code for this. Just like you saw for the snake game, it was the same thing. So I can guess a number, I don't know, 99. It says higher, okay? Maybe 100. Anyone wants to guess?
58.
It says higher than 99.
Oh, that's what it says. So 138 then.
138. It says higher still. Anyone else? Okay, I'll just
200.
200. Oh, you got it.
Oh,
Nice.
So like I said, you can inspect the code for the code for that repository that I shared. But one thing I wanted to bring your attention to is that like looking at the implementation, this implementation is very noisy. It's very hard to comprehend what's happening. And the main reason for it is that it's not composed out of Lego blocks that we can understand. You know, it's as if the code is made out of threads. like threads for stitching clothes together. So just reading this whole thing, I mean, it still has a structure to it, but it's noisy in the sense that we have prompts mixed with like languages, messages, and then they use some generic list and dictionaries from Python, and then there's for loops, and then like it's very, very hard to read, right? So I got tired this morning, but I was trying to re-implement some of this into the structure that I was showing you with the decorators in a way that they can be stacked together. What was my example here? So basically I did through the file writer, I did the initial step, which is knowing how to write files to disk. And in this case, how to write code files to disk, right? So I could add another one for another tool, just like the file writer, but this time it could be like a planner, which will be a tool responsible that can be used for planning something, like planning a game. There will be another tool for collecting feedback and so on and so on. Other tools for reading files from disk and so on and so on. You get the picture. That way, by abstracting away the boilerplate codes and then making them available through Lego blocks or decorators, it's easier to understand what are the interactions, and then compose those blocks into the functionality that we want. So that's it. That's what I wanted to show you today. Any questions? So,
Nothing in the chat.
yeah, cool. Yeah, so now the floor is open. So if anybody wants to say anything or discuss anything.
Brunel and Ben, thank you for taking such interesting concepts and making it compelling.
Yeah, thank you for coming.
I appreciate that. Thank you. You're welcome.
Yeah.
Thank you, everybody, for taking the time to listen. Thanks for Ben and Aziz, for allowing me to present as well.
No, thank you.
Question for you, Brunel. Like, how do you, what do you, I guess, any lesson learned from going through the process, like trying to figure out the LLMs and all that? Like, what was like your biggest takeaway, I guess, or pain points?
I've learned so much, because for me it was more about trying to understand the moving parts, like what does what, and where do you even implement the LLM. At some point I thought that if I had to build like a solution, an AI powered solution, I had to implement the AI on the client side. That's what I thought. But right now I realize it wouldn't even make sense, that type of things. And I've noticed that it was simpler than I thought, to be honest. But if I didn't have this presentation, I would have pushed back, because every time I say, okay, when I have time, I will learn it. When I have time, I will learn it. But because now I had a deadline, I had to learn it. So that was
yes.
No. Well, thank you for taking the time. I really appreciate it.
Thanks to you guys.
Yeah, I think the next presenter is a Kofi, right? You're presenting next time.
Yes, I am. I haven't started though, but I'll be ready.
All right. Kofi is a veteran, so he knows what's up.
Veteran, he knows.
All right.
I'm on the plane, so I'll go on mute.
Oh, okay. All right.
Oh, okay.
Kofi is dedicated. He's been playing. Wow, he's attending the
Yeah.
meeting. That's dedication. All right. Any other comments, questions? I don't have anything. So.
Yeah. So, Afis, you also worked on the presentation, right? What's your? Do you want to share any thoughts?
I would say the part that I built was pretty much nothing that has to do with the AI itself, but I was amazed by the fact that you can just pin out something real quick and then be able to talk to like a back-end API that will be integrated with the like the LLM to execute some stuff. So that was a good takeaway from me, because the number one issue that most people think about is, okay, you know what, I don't want to provide my data to these companies, not knowing what they're going to do with them, right? Because in the end, they're all trying to steal your data. But being able to abstract some of the data and then do all that stuff was a good key takeaway for me.
Yeah. Nice. Nice.
Okay. Well, if there's no other comments, questions, again, thank you for the presenters today, Ben, Afis, Brunel. Appreciate you taking the time. And we'll connect with Kofi to get the agenda, and we'll post it on the meetup. And we'll see you in 2 weeks.
All right.
Have a good weekend, everyone.
1 second though. I
Mhm.
think
Go
was it Northlake? Sorry, that's what your name comes up as. Did you have a question? Because
Yeah.
posted something about looking for a programmer.
He dropped.
Oh, he's blocked. Okay.
No, dropped. He's not here anymore.
Oh, he
Not
dropped.
blocked.
Okay.
Yeah.
Okay, so he left. Okay, but I think he left his contact information in the chat
Yes.
if anyone is interested.
Thanks a lot. And Ben, thank you for like what you worked on. It's pretty solid, and it sets ground for a lot of stuff.
Yeah. Hey, thank you. Okay. Thanks. I'm learning
Thank you guys.
Yeah, I just wanted to say that I'm learning some of those things I know, but some of those things I'm also learning at the same time. So that last part in the presentation, my part, about thinking at a higher level on how to compose like concepts and purposes, like to build something like an agent, like we saw the game demo, right? I think this is where it's going, because from my opinion, the level at which like most people code, whether it's for building apps and things like that, with the LLMs, it's as if we have to level up, to solve a different type of problem, because the trivial things are the more trivial things, most likely it's going to become a competition with a robot in the form of an LLM. So we need to assemble these new concepts and then move to a higher plane. And that's how I'm thinking.
So technically, we all lost our jobs unless we adapt.
Not yet, because in a way, for somebody to prompt, I don't think it's possible for anyone to prompt an LLM to do anybody's job right now, because the reason why programmers are needed is because we need precision. Like I said, trying this agent this morning for the guessing game, I let it run for like an hour. I think I burnt like almost $5 or more on Entropic. But when you suggested the snake game, it got it right the first time. And those errors that it was making this morning, they were not even big errors. It was just like using the wrong syntax and things like that. An actual programmer who has some experience wouldn't make these mistakes. Or if that programmer made the mistake, it would be trivial to fix and move on. They wouldn't spend an hour just fixing a syntax error. So in that way, imagine all those people that that don't know how to code and that want to completely replace a programmer, like the frustration of it, trying to articulate what needs to happen in order to fix bugs. So it's not gonna be like that. I think the competition or the challenges will be more against those that employ LLMs to build stuff versus the ones that don't. Those that use it to build stuff will be able to move quicker or to build more advanced systems more quickly. So it's more like that, I think.
Thank you. And then you answered one of my questions, which was how many tokens does it take to run the repo that you are running?
Yeah.
Thank you.
Okay.
Ben, could you briefly show the ycombinator.js script at the top of your editor? Thank you. Awesome.
Sure, I can copy it for you in the. It's also checked in, I think. This is the generated version. There's one that I checked in. Let me check. Let me see here in the repo. So the file output was JavaScript.
Ah.
I even have two versions. So there's this one, and then there is this one. Yeah, I think it's formatting for also the.
Excellent. Thank you.
I still want to say that this, like looking at the repo, right? Looking at the way they did it, it's unnecessary because this looks like a random number that they could have just generated by calling the random library. But here they're using factorials and they're repeating it. They have a loop and all that stuff. Not sure if all this were needed.
Well, I mean, if you, I don't know if you do any functional programming like Lisp or anything like that.
Yeah.
You do? Okay. So in some situations, there's a need to employ recursion, but it's not really appropriate to go ahead and create to declare another function somewhere else. Right? But here, like, I mean, regular languages, quote unquote, like JavaScript and all that, they are limited. So there's extra syntax to define the same thing. But I think if you look at okay, this is the Racket version. You see, there's less boilerplate. So for example, if you look at here, right, it accepts a function and then it calls that function itself. But when you go down to like weaker languages, then there's boilerplate involved.
Yeah.
So yeah. I mean, it's a useful thing. That's why it has its own name, right? I didn't invent it. It's got to be the right situation.
That's true.
So. Yeah. Anything else? Anybody? Any other comment?
Nope.
Yeah. So John, I pasted the last one for the JavaScript. It's in the chat.
Thank you.
Oh, okay then. So yeah.
Thank you, everyone.
Thank you, everyone.
Bye.
Bye.
Yeah. Okay. Bye.
Bye.
Bye.